space telescopes, they're orbiting around Earth right now, and they're giving us some jaw-dropping images of distant galaxies and stars that are millions of light years away. But how do these space telescopes work, and how are they able to see so far? And what's the science behind it? And why is it important to have these space telescopes pointed at distant galaxies? And how are we getting these breathtaking images, such as the penguin and the egg from the NASA's James Webb Telescope? Well, in this episode, I'm going to take you behind the science of how space telescopes work and take you deeper into how they actually are able to process these images and make them available to people and scientists, and what kind of science goes on behind interpreting these images. Let's get right into this amazing science. Let's go! So, to learn more about telescopes, let's first take a rewind into the history of the telescope. You see, the telescope, we're not sure who exactly invented it, but we've tracked it down to a few people. The first one is Hans Lippershey. He invented the telescope out of eyeglass parts, and he made something that could magnify these things effectively. Another person that's also credited with making improvements to the telescope is Galileo Galilei. He used his telescope to make many different discoveries about Jupiter, Jupiter's moons, and even our own moon. So, these telescopes are much more different than the telescopes we have today, and space telescopes as well, but those are another different story. Now let's take the first step. How do telescopes, the regular telescopes you can buy at a store and that people use on the ground, how do those telescopes work? Well, it's all thanks to mirrors and refraction and reflection of light. You see, they use mirrors to collect light and put it into a certain tube. That's what the tube of a telescope is for. And what happens is that light refracts or bends, and it passes through different lenses and reflects off of mirrors, and that causes the image that you see on the other end to be magnified. And that's how telescopes work. It works by refracting light or bending light, and sometimes even reflecting light if it's a reflector telescope. So it basically works by magnifying these things by taking all the light in and magnifying it, and also making different images that you can see with your eyes out of the lens. And different lenses help you see things differently. And that's how telescopes work. So we just covered how visible light telescopes, or telescopes that you can buy and use at home, work. But what about these bigger telescopes, like the James Webb Telescope and the Hubble Space Telescope? The Hubble Space Telescope uses visible light as well, and it uses giant mirrors in order to reflect the light into instruments. It can also pick up other different types of radiation, but not as much as the James Webb Space Telescope. It focuses on infrared radiation, and that means that they're able to see more images in a different wavelength. You see, there's this thing called the electromagnetic spectrum. It's made up of radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, and gamma rays. Visible light is what you can see, and that's a very limited thing. But when you're able to see many different wavelengths, especially infrared radiation and microwaves, you're able to see you're opened up to a wide variety of things you can see in space, such as galaxies and different remnants of the Big Bang, and so many other things. And James Webb Telescope is built to observe all of these infrared frequencies and radiation, meaning that you're able to see a wide variety of things in the sky. And we're able to get breathtaking images of different galaxies, even galaxies colliding, like the penguin and the egg that got released recently. This penguin and the egg galaxy is actually two galaxies that are converging together. And James Webb actually released this image recently to mark its second anniversary on July 12th. Now, this telescope is able to observe all of these different wavelengths. It's a lot more complicated than just observing visible light, because you have to have instruments and people that are able to interpret the data that the telescope gets. That's why on different types of space telescopes that are built to observe different types of radiation, they're able to use computers and technology and even human help in order to decode these images, because they're not the same as just looking at the images through visible light telescopes. You have to kind of decode it, you have to put it together, you have to layer it in order to get the full picture. And that's what James Webb Telescope and other telescopes that are able to observe infrared radiation and microwaves do. That's because James Webb Telescope especially has these giant mirrors that are able to reflect light into a central area. And that is what takes all these pictures through infrared radiation. And those giant mirrors help the infrared light bounce off of it and help put it all into that sort of camera-like feature. And all those instruments inside James Webb Telescope and other space telescopes, those are what help decode all of these images. And that's how space telescopes work. They're these giant mirrors that are reflecting all these types of light. They can be visible light. They can also be different types of electromagnetic waves, such as microwaves and infrared radiation, and they reflect all this light into these instruments, and these instruments are able to process it and give us these breathtaking images that we see. It's kind of like photos from space. It is so amazing to see all these breathtaking images and all the data and new scientific discoveries that are coming from the space telescopes. That's why scientists are launching space telescopes. It's to help us understand space better and understand the origins of the universe better, because as you look further and further out, you start to see lots of different galaxies, stars that are forming, stars that are dying, even exoplanets and planets that might be able to support life. It is amazing to see the science that's happening above us, and it is just amazing to see all the different types of pictures that you're able to see. And it's not just scientists that have access to these pictures. You can also view all these pictures that Hubble, James Webb, and other space telescopes are processing and releasing. So it's just awesome to see all the science going on around us, even above us and in space. Alright, let's review what we learned in this stellar episode of Spectacular Science. In this episode, we learned that space telescopes work differently from the regular telescopes you have at home. And the regular telescopes that are on Earth are called visible light telescopes, and they take in light through mirrors and lenses, and they refract light or bend it, meaning that you can see zoomed in images very clearly. And that's how telescopes are able to magnify things such as the moon. Meanwhile, space telescopes are able to observe a wide variety of electromagnetic spectrum radiation. That includes radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. And they're able to observe all of these, and especially the James Webb Space Telescope is able to observe infrared radiation, meaning that you can see a wide variety of things using this telescope, and it's able to expand the horizon for more scientific discoveries and more breathtaking pictures like the penguin and the egg. And it's just amazing to see all this science going on currently and above us. And it's just so cool to see how all these space telescopes work, how all those sensors are able to, and the mirrors are able to reflect the light into the sensors, and those sensors are able to give us these amazing images that we see today. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay Raman. Our theme song and additional music are by Charan Ramachandran. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you want answered on a Spectacular Science episode and get a special shout out? Well, grab an adult and head over to spectacularsci.com/contact. There you can find a contact form. You can send me your amazing science questions. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science. Oh, and yeah, don't forget to subscribe to this podcast wherever you're listening right now and share it with your friends and family. Thank you so much. Alright, keep thinking about science and see you in the next one. Bye!